Alright, welcome back. This is Ahmed for Avionics, and this is Mastering Docker course. This is section 3. We are discussing Docker containers. Now, in the previous lecture, we have seen how we can create two containers, and using the link flag of Docker, we were able to link those two containers together and make them see each other and interact with each other. But in the last section of the last lecture, we have seen how we can run both containers in the background, and this makes us unable to see any output that any of those containers is printing to the screen. And actually, let's have a look at our system. We are interested more in the output of the checker command, not the runner command, because as we said in the previous lecture, the runner command is just a loop that will run indefinitely in the background. It will do just nothing and it will print nothing to the screen. But the checker, as we have seen, is printing system is up as long as the server container is running, and as soon as the container exits, it has to write system is down. So let's see how we can have a look at this output. First, let's start again this server, because it has to be started in order for the checker to be able to start, and this can be accomplished using docker start command. Docker start just starts the container, and let's have a look at our containers again. Now, yes, server has been started, and now let's start also the checker command, and notice that it starts with the options that we have specified during the creation time. We use docker run, and we specified that it's going to be linked to a container that is called server, and the other options that we have specified that it is working in the background, and it's going to have a name of checker and so on. All these options are retained when using docker start command. So let's start the checker. Okay, let's have a look at docker ps. Okay, and we have two containers up and running. Now, in order to have a look at the output of the container, we use docker logs. Okay, so it's docker logs followed by the name of the container or the ID, and in our case it is checker. As you can see here, these are the messages that has been typed when the container was up and running, when server was up and running, and this message was printed right after the system got down. This is right after the system was stopped. When we stopped the container called server, the checker sent a ping request to the server container, and it, of course, did not find any reply or any response, so it just typed server is down, and the command exited, causing the whole container to exit. And when we start it back again, as you can see here, because we started server first and then we started checker, the server is up message is being printed again. And actually, logs command has another useful option, which is -f. -f will let you just use the logs command just the same way you use the tail command. If you are working with Linux, you of course know that tail has a very important option, which is -f, which makes you, as you can see here, update the content the moment it have an updated view of the content, and any new messages that are printed to the logs are immediately appearing on the screen. So this is very useful if you want to follow the messages that are being output from a service or a container. Now, we have used docker ps more than a couple of times in this lecture and in the lectures that was before it. Let's have a closer look at the output of this command. Docker ps lists all the containers that are currently running on your system. If the container is stopped, it won't be displayed by default if you have docker ps. Now, as you can see here, the output of docker ps contains 7 columns. The first one is the container ID, and we're going to discuss container IDs next in this section. And we also have the image name on which the container was based or was built from. Here we have /checker and /server. We have the command that is used by the container to run. Here it's checker.sh, and in the server it is runner.sh. This is the amount of time that elapsed since the creation of the container. And notice here that the creation time has nothing to do with the state of the container. So whether the container is running, stopped, restarting, or in any other state, this will not be affected. It will always display the amount of time that has elapsed since this container was created. And this time is only reset if the whole container gets deleted. And this is the status of the container. We're going to discover the status of containers later in this section. It's up here. This is the status. The status is up, and this is the amount of time that has elapsed since this state has changed to up. So it is up for 2 minutes, but it has been created since 10 minutes, okay, or 10 minutes ago. This column here contains the ports, and these are any ports that this container exposes. Like, for example, HTTP ports or MySQL ports and so on. And finally, we have the name of the container, the name that we have chosen for the container. Now, we have also seen in the lab that we have used a number of commands to deal with the containers. We use docker stop, docker start, and we have also docker restart, which we did not use, but docker restart just executes docker stop and docker start sequentially. And these commands, of course, are self-explanatory. The docker stop will stop the container. The docker start will start a stopped container. Docker restart, as we said, will issue a stop, then a start command. But notice here that we can interact with the container not only by the name, but also by the container ID. Okay, now the rest of this slide is talking about Docker logs. We have already seen that in the lab. And notice here that those commands can interact with the container both by its name or by its ID. And by ID here, I mean this container ID. Okay, those 12 characters that you see here, this is the container ID. This is a unique string that identifies each container in the system. It is very, very less likely that any collision might happen out of those randomly generated strings. However, and as we are going to see later in this section, this is not the full container ID. The full container ID of the container will contain about 65 characters. So this is just the first 12 characters of the container ID, and they are, as we said, they are enough to address a container because the probability of a collision happening on the first 12 characters of a container ID is very, very less likely to happen. And that brings us to the end of this lecture. My name is Ahmad for Avionics, and see you next.